And we'll go ahead and get started. So my name is Sarah Zack. I'm the Pollution Prevention Extension Specialist for Illinois Indiana Sea Grant, and I'm based at the University of Illinois. Illinois Indiana Sea Grant is a bi-state program, and we cover the Illinois and Indiana coastline of Lake Michigan. But we work really closely with the Great Lakes National Program Office at EPA, with NOAA Marine Debris Program, with a lot of partners in the area to try to tackle big Great Lakes problems. And so my focus is pollution, essentially, pollution prevention. And so what that has meant lately is talking about contaminants of emerging concern. And so CECs, or emerging contaminants, and what these are contaminants that are in our natural waters at really low levels. We have concerns about them having negative impacts on aquatic life, on things that live in the water. They don't have any regulatory standards. There's no drinking water standards or anything like that. And they've been recently, quote unquote, discovered, typically because we've improved the way we can detect those chemicals. They may have been there all along, but we're just now starting to learn more about them and where they are and the problems that they cause. And so this includes things like persistent organic pollutants. Two classic examples of those that I think most people are probably familiar with are flame retardants, or PBDEs, and then your non-stick and stain repellent chemicals, or PFASs. And PFAS has been in the news like crazy lately. That's really the emerging contaminant of emerging concern. It includes other things like pharmaceuticals and personal care products, endocrine disruptors like BPA, nanomaterials, carbon nanotubes, and then titanium dioxides like those that are in sunscreens. And then microplastics and what we call anthropogenic debris or man-made debris get kind of lumped in here. They're not chemicals, right? But they are contaminants because they contaminate our water. So as we kind of turn to talking about plastics, I just want to kind of take a minute and kind of back up a little bit and talk about plastics and have you kind of think for a sec about what the most common thing is in your trash at home. Is it made of plastic? Do you separate your recyclables? Do they all go in one place? Are you able to send them, to a municipal recycling facility? And how much trash do you think you generate in a day? And for reference, a gallon of milk weighs about 8.5 pounds. So how much trash do you think you generate in a day? Well, according to the EPA, every person in our country generates almost 5 pounds of waste per person per day. So we generate nearly 300 million tons of garbage over the course of a year. And half our garbage ends up in the landfill. And another about 30% of it ends up either recycled or composted. And then around 12% of it ends up combusted. And that's a great solution because then often the heat from that will power homes or businesses. But what we've learned is that the pace of plastic recycling, we're only recycling, what was it? It was about 23.6% of our garbage is being recycled. And in terms of plastic specifically, the pace of our plastic recycling has not kept up with how much plastic we have generated over the past, 60 or so years. And you can see really clearly that plastics generation is just skyrocketing, while recycling, is really, really moving at a much, much slower pace. And that has to do with the plastic boom over the past, 100 or so years. Synthetic plastic was first introduced in 1909. And really in the late 40s and early 50s, we saw the advent of the disposable lifestyle. Tupperware was invented, and it was the greatest thing since sliced bread. Shortly after, plastic bags were invented. And by 1976, plastic had become the world's most used material. And that was before plastic bags were even introduced into grocery stores in 1977. The plastics industry really promoted the convenience of using things once, right? And by the 70s, throwing things away and being disposable was kind of a way of life. And that's primarily because the production costs for creating 1,000 or 10,000 units of something made of plastic are pretty much the same. It's the setup, whereas where the cost lies. And so by sort of resolving and creating this convenience, and this disposable lifestyle, we've really created our biggest challenge yet, which is all of this waste and the effects that it has on the environment. So a study came out in 2017 where this group of researchers figured out and did the first global analysis of all mass-produced plastics ever manufactured. And this is a really important study. And what they found was that about 8,300 million metric tons of plastic have been produced in our history. 8,300 million metric tons of plastic. Of that, about 30% is still in use today. About 55% has been discarded, and it's either in the environment or to waste facilities. 8% has been incinerated, and only 7% has been recycled. And the interesting thing about this is that what this tells us is that 92% of the plastic that was ever produced still exists somewhere in some form. And that's because incineration is really the only way that plastic gets discarded, gets transformed, gets actually broken down into gas and waste. So 92% of the plastic still exists somewhere. Now, another study estimated that about 10% of the plastic that gets produced each year enters aquatic habitats. So 10% of our plastic that we're making every year, of which we're looking at about 200 to 300 million tons of plastic that we're making every year. And 10% of that is ending up in the water. And so that means that 20 million tons of plastic every year is ending up in aquatic habitats. And that is just an astronomical amount of plastic. And the plastic that ends up in the environment has several fates. And I'm primarily going to talk about the stuff that ends up in the water here. It's most frequently discussed about litter and debris in the oceans. And so we see that it accumulates. It accumulates both in the water and on the shorelines. It gets ingested, like this seabird that died with, you can see copious amounts of plastic in its gut. And it breaks down and decomposes. And that's what we're going to focus on primarily for the rest of our time together. So it breaks down and decomposes into tiny plastics, which we call microplastics. And you can see a few here, these tiny blue little beads. Those are not natural. Those are tiny pieces of plastic. So microplastics are small pieces of plastic that are less than 5 millimeters in size. And we divide them up into sort of two different kinds, primary microplastics and secondary microplastics. Primary microplastics are those that are created in microplastic form. So a good example of those is production pellets, or what Natalie and I were just talking about. These are called nurdles, which is one of my favorite things to teach people about, because it's a fun word. And everybody should make a pledge that they're going to teach a friend about what nurdles are when they go get off Facebook tonight. So production pellets, or nurdles, are tiny beads of plastic that are used as raw material to create larger plastic goods. A great example, if you're familiar, if you've been to Brookfield Zoo or the Shed Aquarium or Lincoln Park Zoo or any of those areas in Chicago, and you see the mold-orama machines where you can put in $1 and you can make a molded animal or a molded fish, they're using nurdles to make those molds. Anything that's molded out of plastic was made from nurdles. The other kind of primary microplastics are microbeads. These are polyethylene and polypropylene beads, small beads that are used in the cosmetics industry. And they're very, very tiny, much smaller than nurdles are. Nurdles can be found with the naked eye. Microbeads are very, very small, but they aren't retained by wastewater treatment plants, and so they end up in our waterways. Then we have secondary microplastics. Secondary microplastics are those that break off from larger pieces of plastic. And these are the ones that we can really make a big impact on because we're sort of in control of those larger pieces of plastic, like water bottles or food wrappers. So we're talking about fragments, little pieces of styrofoam, like the little beads of styrofoam from styrofoam coolers, and then little pieces of plastic film. And then we have synthetic fibers or lines. And these are small fibers that rub off or come off of our clothing primarily. Carpets, our clothing, really any good that's made with a fabric made from a plastic-based material. Nylon, polyester, things like that. And so this is sort of what this looks like in real life. So up in the corner, this is a 2-inch disc of filter paper. And then a close-up here. And you can see on this filter paper, they filtered out a water sample, and there are a number of microplastics on it. So we have a fragment here. There's actually a fragment here and a fragment here as well. So pieces of larger plastic. A little piece of foam right here. A couple of fibers in there, and then a nurdle right there, a pellet. So you can kind of get a feel for just how small these things are. So where do they come from? Well, we find fibers a lot from clothing and domestic wastewater. Wastewater that then gets discharged into our natural waters, into our lakes, into our rivers. And even though wastewater treatment can remove up to 99% of these fibers, that 1 to 25% that gets through the wastewater treatment plant represents an enormous amount of tiny, tiny plastics. Tens of thousands of fibers on a regular basis just being discharged because wastewater treatment plants were not designed to remove fibers from water. They're found in personal care products less frequently, which we'll talk about later, but microbeads in personal care products are incredibly rare. They are one sort of success story that we can claim in terms of reducing the amount of microplastics that we input to the environment. They get moved around through runoff on the ground, rainwater that pushes things into storm drains that then pushes things out into our waters and then get moved from upstream into downstream ecosystem. And as that's happening, these larger pieces of litter are breaking down into smaller and smaller pieces of microplastics. And as we talk, especially once we start talking about solutions, which we'll kind of wrap up with, I'll sort of bounce back and forth between talking more broadly about plastic debris and then also narrowing it down to microplastics. And this is why, because one of the biggest sources of microplastics is the breakdown of larger plastics. So we have to focus on those to reduce microplastics as well. So we know that microplastic is everywhere. It's pervasive, it's persistent in marine ecosystems. There's been just a ridiculous amount of research on microplastics in marine ecosystems. And this is sort of a timeline, and I want you to focus on the blue text. We already kind of talked about this plastic, the industry growth. So we're gonna focus on the blue side, the ocean environmental studies side. And I just wanna highlight a couple key dates for you all. And so the first is in 1973. Research found that marine pollution caused, quote, considerable harm. So we knew back in 1973 that marine pollution was a problem and was going to continue to be a problem. In 1982, research first found that plastic was detrimental to marine birds, that it's a bad pollutant for marine birds. In 1987, we determined that most, if not all of this ocean debris is coming from land. It's not coming from the water, it's coming from land. Now, the exception to that would be things like ghost nets and fishing debris, which is originating from boats that originate on land, but it's actually being input at sea. In 1999, research found that plastic outweighed plankton 6-to-1. So those are very important food web repercussions, right? If plastic is 6 times more plentiful than a major food source, that's going to cause problems over the course of time. In 2010, fish were found to be eating plastic in the Pacific Gyre. And then in 2016, and this was a big deal when it came out, this was all over the news in 2016. The UN put out a study estimating that there were 5.25 trillion pieces of macro and microplastics in the ocean. That's a lot of plastic. That is an amount of plastic that I'm not sure we can hope to ever remove. So that means cutting off inputs of more plastic becomes even more important. So we know that microplastic is pervasive and persistent in the ocean. Well, we also know that microplastic is pervasive and persistent worldwide. Only recently have we started to look at bodies of water like the Great Lakes. And this is a study from 2013 where researchers looked at Lake Superior, Lake Huron, and Lake Erie. Sadly, they skipped Lake Michigan. But this was the first study of microplastics in the Great Lakes, and it was in 2013. That's not that long ago. So it shows you how kind of new this body of research is. But you can see pretty clearly here that there are a lot of microplastics in the Great Lakes. Looking over by Buffalo and Erie, we're looking at plastics over 100,000 per kilometer squared, which is a lot of plastic. Well, the fact that that study didn't look at Lake Michigan left an opportunity for us. So shortly after that paper was published, my colleagues at Sea Grant got together with some colleagues at Fredonia, State University of New York in Fredonia, and we conducted a survey of Lake Michigan microplastics. And as you can clearly see here, we found microplastics everywhere we looked for microplastics in Lake Michigan. And this was the first study that actually documented that. And really, we were looking for microbeads. Microbeads were what we expected to find. Microbeads had been a pretty hot topic to date. So we were really expecting that these microbeads, the ones from personal care products, the ones from face washes and body washes, we thought those were just going to be everywhere. And if you look at the studies, this Erickson et al., that's the first study that didn't look at Lake Michigan. And you can see that primarily what they found were fragments, so chunks of water bottles and larger plastics, and pellets. And these were microbeads. It was about 50-50-ish. Lots of fragments, lots of microbeads. So that's really what we were expecting to find, when in fact, that is not what we found. We found a lot of fragments, some microbeads, and a lot of fibers. And this was a huge surprise. We did not know anything about fibers at this time. Microbeads were in the news. We were finding them in all sorts of bodies of water, but nobody was talking about fibers. And so this study that we did on Lake Michigan was one of the first to really highlight the volume of plastic fibers that were in Lake Michigan. And it really highlighted some research gaps. And there's a couple things to say about that. One, that we probably didn't sample the exact same way as that other study did. We obviously didn't sample the same places. Water moves from place to place. Things in the water move from place to place. Wave action, storms, settling out, new inputs. There's all kinds of things at play here. And so what that highlights to us is the research gaps around microplastics. There's a lot that we don't know. There's no standard method for sampling microplastics. Some people go out and they just take a jar and they just grab a sample of water. Other people trawl with a net and then wash it down and look that way. And different nets have different sized holes and can capture different sized plastics. And there's a lot of work that needs to be done to standardize those methods so that we can compare studies and compare locations and compare over time. And the other big thing is the effects of microplastics. And that's what I'm going to turn to next. What are the long-term impacts of microplastics? What are the impacts of microplastics on the health of a fish or of a frog or on the ecosystem that they're living in? We don't know a lot about that. And that's evidenced by this article I just found today when I was preparing for this. This is an article from May of this year, and it's still asking the question, are they harmful? Are microplastics harmful? Scientists are rushing to study the tiny plastic specks that are in marine animals and in us. We know they're there, and that's sort of the timeline, I guess, is the first step is identifying what they are. The second step, I guess, is identifying where they are. And then lastly, once we've kind of figured that all out, well, what's the effect of them? And I think a lot of people are still figuring out how many of them and where they are and what kinds there are. And we're just now turning to try and figure out what the real harm is. Because if they've been there all along and we haven't really seen any impacts from them, then are they harmful? And it's a valid question to ask. And science, we need to use science to tell us for a fact whether or not they are harmful before we spend money and energy cleaning them up or things like that, because otherwise we're just throwing good money after bad. And so we're starting to see a lot more studies come out about the impacts and the effects of microplastics. But a lot of them are laboratory analysis, where they take one certain species and they feed it a certain kind of microplastics and they look to see what happened. They're not real world examples. And so what we did at Sea Grant was try to look at the whole body of research about the impact of microplastics. And we did that by doing what's called a meta-analysis. And this is something that's done very frequently in the medical community as well. And this is a statistical technique that allows researchers to assess effects. In this case, the effect is exposure to microplastics. And they're assessing it over multiple studies conducted in different locations, on different groups of organisms, and even by different research groups in order to understand what the broader potential impacts might be. So it's sort of like looking at that whole body of research and being able to glean trends, essentially. And so we did this for microplastic effects. And we've seen a lot of literature out there about the ecological impacts. We've seen studies that said that there were negative impacts on different types of organisms because of ingesting microplastics, for example. They demonstrated that when a big fish eats a small fish, those microplastics get transferred into that larger fish when they eat their prey. Some studies had shown decreased reproductive success and decreased survival. Others had shown changes in ecosystems, primarily by changing the microbes in that ecosystem. And we'd seen impacts in terms of the toxicology too. We know that plastic leaches chemicals. Some plastics have BPA, right? BPA is an endocrine disruptor that can cause negative impacts to people and animals. And so we know that that's something that plastic does. We also know that plastic can absorb chemicals. Okay, they can easily absorb those persistent organic pollutants that I was talking about. And research has shown that different plastics have different risk factors about how much and what kinds of pollutants they can absorb. So this study from 2013 looked at a variety of different plastic types and found that high density polyethylene, low density polyethylene, and polypropylene absorbed pollutants at a higher rate than PVC and PET did. So there's a lot of information out there, but collectively, what does it mean? And so that's why we did this meta-analysis. So we looked at 43 different studies, and in order to be included in our analysis, they had to have measured at least one effect of exposure to microplastics on an organism. It had to have been an experiment. They had to have included a control so that they could actually see whether there was an effect or not. And they had to report certain types of statistics. And they accounted for something called publication bias. And again, this is something that is that's very well known in research communities, probably not very well known out in the public, but publication bias is, it's a natural phenomenon. It's the tendency of researchers to kind of let the outcome of your results dictate whether it gets published. So in other words, it's a trend that sort of negative results or no results or quote unquote bad results don't get published as often as research that indicates something strong. So in this case, that might mean that if you're doing an experiment and you're feeding microplastics to fish and nothing happens to them, you might be less likely to publish that than if there was a drastic, dramatic negative effect or a positive effect for that matter. And so statistically, we were able to account for that and sort of throw out those outliers and get down to what the studies were actually telling us. So the question we asked was, what is the impact of microplastic exposure on consumption and feeding of organisms, on the growth, the reproduction, and most importantly, the survival of organisms? And we found that the effect really varied depending on what kind of an organism we were talking about. So we had 6 categories of organisms: zooplankton, which I like to call tiny animals, sort of the base of the food chain; echinoderms, which are sea stars, sea urchins, a kind of invertebrate; mollusks or shellfish; macroinvertebrates, which are insects that spend their their juvenile stage in water; larval and juvenile fish, and then adult fish. And you can see that there were no real clear trends. A number of species had some significance. Zooplankton microplastics had significant negative effects on growth and reproduction and survival of zooplankton, and had significant negative effects on the consumption habits of larval and juvenile fish. But otherwise, it was just sort of possible negative effects, or no real negative effect was seen. So what does this mean? So we think that these findings kind of support the concern over plastic pollution in aquatic ecosystems, because these effects were generally negative or neutral. They were never positive. Plastic was never adding something positive to these organisms. It was always a negative or a neutral interaction. And there were some significant negative effects. And the lead author on this study, my colleague Carolyn, she likes to say that there were no slam dunks in this research. She likes to make that clear because these are trends that we're looking at, right? But it looks like zooplankton are the most susceptible to microplastics exposure. So as you can see, them being negatively impacted significantly by growth, reproduction, and survival, and that's not great for zooplankton. So what does that mean beyond that? Well, this is the Lake Michigan food web, and it's a very simplified version of it, but it's a good chart. And you can see in green at the bottom, these are phytoplankton or tiny plants. In blue, we have zooplankton or tiny animals. And then in orange, we have invertebrates. And then in blue, we have small fish. And in purple, we have sort of large predatory fish. So if microplastics are negatively impacting zooplankton, sort of near the bottom of the food chain, that's going to have negative impacts all the way up the food web. If, for example, a yellow perch right here can't find any of these to eat anymore, their diet is impacted, their survival is going to be impacted, their reproduction is going to be impacted, which means that there's less food when you get up to the top of the food web. So living, on Lake Michigan, as we do, with a multi-million-dollar fishery, these results could be meaningful in terms of the health of the food web of Lake Michigan, which a lot of people's livelihood and recreation depends on. So all in all, we feel pretty comfortable saying that microplastics are worth being concerned about. And then there's us. We know they're having impacts in aquatic ecosystems, we've been doing that research for a little bit longer. We're just now starting to turn and start looking at how microplastics are impacting us. Microplastics have been found in all kinds of consumable salts: sea salt, lake salt, rock salt, well salt, chicken gizzards, random, honey, beer, tea bags, drinking water, both bottled and tap. They've been found in seafood and shellfish. And a study came out in 2019 that finally, for the first time, quantified human consumption of microplastics. And it found that we consume 52,000 microplastic particles per year. That's a lot of microplastic particles. We also inhale 69,000 particles per year. So over 100,000 particles per year. And just to add some more good news, if you only drink bottled water, there's another 90,000 microplastics particles per year. If you only drink tap water, you only add another 4,000. So I say that's even more justification for ditching bottled water and investing in a good reusable water bottle and just drinking that good old tap water, especially if you live someplace where you're drinking lake water. So, and I did want to say one more thing about this. So as I said before, the sort of trend in microplastics research has been first figure out what they are, then figure out where they are, then figure out the impacts. So we've done the what are they, and that's the same for us and for the environment. We've done a lot of research on where it is in the environment, although we're still seeing a lot of studies finding microplastics in different places. I just saw a study that found microplastics in karst aquifers. Who knows how that microplastics got there? We're still working on figuring out where it is in our world, right? In our food and in our bodies and how it gets there. We're still working on the where for humans. And I expect that the impacts will likely follow, but it's going to be a lot harder to figure out what the impacts to people are versus impacts to fish or zooplankton or something like that. We aren't good with lab experiments on people. So it's going to make that very challenging. So I expect that we're really at the very beginning stages of figuring out the impacts of microplastics on people. So let's turn to solutions. So, and I'm going to kind of frame this as questions. So whose responsibility are these solutions? And let's look broad, right? Plastic solutions in general first. So do we need to be talking about the consumer or the corporation? That's the first sort of question I want to tackle. And we have a big emphasis on personal responsibility, and rightfully so, right? You vote with your wallet. The choices that you make have an impact. But there are a lot of people that argue that corporations bear the lion's share of the blame for the global plastic problem, and they would be right. Research has found that 20 firms are responsible for over half of the world's plastic waste. So ExxonMobil is the leader there. They're the #1 corporate plastic polluter worldwide. And if you look at global beach cleanup data, Coca-Cola gets the honor of being the #1 global top polluter from breakfreefromplastic.org because it is the #1 brand that is found on beaches globally. So while I think it's important that that we choose personally responsible and we make decisions with personal responsibility in mind, that we choose tap water over bottled water, that we give up single-use plastics as much as possible and things of that nature. It's also worth it to bear this in mind so that we can continue as a part of that to put pressure on these corporations to start bearing the responsibility of the pollution that they're creating. So another way that people would like to see solutions come out to this problem is through legislation. And you sort of see two sides of the coin there too. Do we legislate it away, or again, is it personal responsibility? Whose responsibility is this? And we have seen a lot of legislation, nationwide over the past, I would say 10 to 15 years start to come out. The first plastic bag ban, I believe, was in San Francisco in, I want to say 2007. And so that was sort of they were sort of the trendsetter as far as that goes. But we've seen more states, more municipalities come out with these things. So Minnesota having a straw ban. And I'm just focusing on ones in Great Lakes states right now. If I looked worldwide here, or nationwide, sorry, it would just be too much information. But we've seen some plastic bag bans in terms of a bag tax, like Chicago has. The city of Evanston, north of Chicago, has a ban on plastic bags. But then you see states like Indiana, Michigan, Minnesota, and Wisconsin that have a ban on bans. They are not allowed. No municipality is allowed to ban plastic bags in those states. Single-use plastic bans. New York has a statewide styrofoam ban, which is incredibly progressive. And Minnesota and Pennsylvania both have some local bans, municipal bans on either styrofoam or straws or other single-use plastics. And these are all very, very helpful, but there also is a lot of pushback on these as well. You see a lot of pushback from communities that are concerned about disability rights, straws, being able to find a bag, not having to pay for a bag, and things like that. These are all reasonable bones to pick, let's say, with legislating this problem away. But we also have had successes in terms of legislative solutions as well. And the number one is the Microbead Free Waters Act of 2015. And so when this passed in 2015, it prohibited manufacturing, packaging, and distributing any rinse-off cosmetics that contained plastic microbeads. So as of the end of 2019, we now have no rinse-off cosmetics, no face wash, no soaps, no lotions, nothing like that that's over the counter that contains microbeads. So the only microbeads, in theory, for the most part, that we find in the environment are those that were there already. And this is a great thing because we were adding a ton of microbeads to our waters, and with no real solution for removing them, because wastewater treatment plants simply cannot remove plastic pieces that are that small. And Illinois Indiana Sea Grant would like to take a little bit of credit for this. After our study came out, after the 2013 study came out, there was a group within Illinois, of which Illinois Indiana Sea Grant was a part, and this predates me. But they were able to put some pressure, and the governor of Illinois, Governor Quinn, was set to sign statewide legislation banning this when the federal government stepped in and said, you know what, this is a good idea. We're just going to create a nationwide act and ban it. So it was really very swift federal legislative response. Very unlike what we're seeing these days, I guess, but a very swift, decisive action to stop the spread of microbeads, further spread of microbeads into the environment. So then we also have engineering solutions. And again, is this something that is the responsibility of the consumer to purchase? Or is it the responsibility of, let's say, a municipality? And here I want to focus on wastewater in particular, fibers in particular. So we have fleece. Every time we wash a fleece, it releases thousands of microplastics, fibers in particular, into the wastewater. That wastewater then goes to the wastewater treatment plant. Is it my responsibility to try to prevent more microplastics from entering the wastewater? Well, there are solutions in the marketplace that I can purchase in order to reduce my personal input of microfibers into the environment. You have the Guppy Friend. This is a washing bag that you can buy online and at Patagonia stores. You put your fleece in the bag, wash it in the bag, fibers get trapped in the bag, and you can kind of clean it out like a lint trap. The Cora ball, you can buy these at like museum gift shops. I know they sell it at the Shed gift shop. You can buy it online as well. It looks like a koosh ball that you throw into the washing machine, and it captures fibers as it washes. And again, you just kind of go in and clean out the lint from inside from in between, I should say, all of the little pieces. And then we have filters. This is the Lint Lover, it's called. It's a Canadian product. It's a filter that you install on your washing machine, and it filters the water before it goes to the wastewater treatment plant, before it leaves your house. And in that tube-like filter right here, captures all of the fibers. And you can just go in, unscrew it, go in and clean it out and remove those fibers. But is it my responsibility to buy a Lint Lover, let's say, at $150 a pop and install it? Or is it a municipal responsibility to upgrade wastewater treatment plants to remove those fibers before they put them out into the environment? These are questions that don't really have very good answers. But if you look back at all these things that we've kind of talked about here, having personal responsibility, reducing single-use plastics, putting pressure on corporations that are large polluters, pushing for bans if that's in something that you're interested in, or just simply choosing not to use these products, right? Not using single-use plastic products. That you can't buy those anymore, but perhaps buying one of these things. These are all different choices that we can make to help reduce our microplastic and our plastic input into the environment. There are lots of options. Even though microplastics are very, very small things that we can't always see, the fact that we can reduce our larger plastic consumption in order to reduce potential microplastics, the fact that we can make choices that will reduce microplastics, like fibers being inputted directly into the environment, gives us a lot of options. The problem that we've seen recently, though, and this is what I want to close with, is sort of the wrench that COVID has put into a lot of people's good intentions. You know, there's been this new emerging body of research just within the past year that researchers really mobilized very quickly to evaluate how COVID was going to impact every aspect of our lives, and how it impacts the waste stream is an incredibly important question to ask. A study that I just saw found that PPE, personal protective equipment, is a new emerging source of plastic pollution in the Great Lakes region. They did a survey, found that disposable gloves were found in the environment at the highest rate, followed by face masks and then disinfecting wipes. Found them in things like grocery store parking lots, places where they're going to, after a rain, get washed into a storm sewer and end up in our natural waters. And another sort of unfortunate and unintended consequence of the COVID world now is that a lot of good that had been done, a lot of, we've chipped away at the problem a lot legislatively, and a lot of that work got put on hold by COVID. And single-use plastic bag bans were the biggest loser in that. Philadelphia had a ban that was supposed to be enacted in July in 2020, and it was put on hold because of COVID. If you remember, in the early stages of the pandemic, no stores were allowing reusable bags. We had a lot of uncertainty about how COVID was transmitted. We knew there was research that said it could live on surfaces, and so reusable bags were one of the first things to go. And so these plastic bag bans that were set to be enacted either got rescinded or put on hold. So Philadelphia's ban got put on hold. California had a ban for years. They lifted the ban, allowed reusable bags for a period of time to try to, as a public health measure. Maine had a ban that was supposed to be going into effect. Again, it was delayed and has been delayed going into effect. So we've seen a lot of those types of a lot of that type of activity. And another thing that I haven't seen as much research about, but I'm looking forward to seeing some, is the increase in takeout containers. Without being able to eat in restaurants, a lot of people were partaking in takeout, and all of that takeout was coming in throwaway containers, right? Of which I imagine a very high percentage is plastic. And so we have to tackle this new problem, this new wrench in the plastic world. And I think that's okay. We've made this headway. We know how to fight this fight. We know how to get these bans in place. We know how to start we know how to organize cleanups. We know how to do these things. And so now we just have to make sure that we address these issues as we're addressing the other issues. It's just another wrench that COVID has kind of thrown at us. But I think that we all still have the right tools to be able to tackle this and get through this, without problem. And I think hopefully in a few short years, hopefully in less than that, but in a very short time, we'll be right back where we were in terms of the headway that we were making in reducing single-use plastic and reducing the inputs of large plastics and microplastics into the environment. So with that, that's all I have for you.